joining our Beyond Our Value session here. I've been informed that both Jacob and Chris are actually pixelated and they're working with a filter right now, which I don't believe is entirely true. Apologies to getting the graphics a little off there, but I'm Jason Todd, Director of Building Science and Industry Support. We've got Jacob Deva Racusin on the call and Chris Magwood. Jacob and Chris were instrumental in the developing and moving forward and sharing the BEAM tool. Chris has been involved in various things, Builders for Climate Action as well, and now is with RMI. And before we get going, I'll just run through a few slides that many of you who have been on our sessions in the past are probably familiar with. TimberHP is a wood fiber insulation manufacturer based here in Maine in the Northeast. And our focus I usually describe as somewhat of a three-legged stool. They all come together in our opinions to provide an insulation product to the industry that meets high performance needs, is cognizant and aware and targeted towards providing a healthy planet and also healthy people in all of the things that we do. And I really have always appreciated this as our sort of pathway forward, because each of us comes to the built environment from different priorities and from a different stance. And I think all of these are relevant and valid, but maybe one speaks to you greater than others. All of our product lines, which we are finally now producing, TimberFill, TimberBatt, and TimberBoard, are really intended to be above grade solutions. The focus here on attic installations, cavity insulation, and continuous exterior. And the highlight of our raw material, I will say, is really maximizing this quite abundant waste resource. The history of paper making in the US, many of you are aware of, is in decline, and the shifting of those raw materials, of those forest products, of silviculture, of board production, were leveraged quite well in a stream of opportunity for many of these mills and wood products providers. And I feel like we are one of a number of manufacturers that are stepping in and filling that void, and that is a critical thing when we talk about better utilizing wood products, which have, I think, at times a mixed result when we talk about carbon emissions. And one of the main reasons, and we're happy to present, is that we finally have some numbers to back up some of the very effective marketing, I think, in many ways, but everyone needs some information, some data behind that. We've published TimberBatt just recently. We are closing in on TimberFill in environmental product declaration, and we will also be looking to produce a pre-EPD. We don't quite have enough data yet, operational data, for TimberBoard, but we have enough to catch a snapshot. And then we'll leverage the tools that we're using currently to generate these life cycle assessments and EPDs to amend as we get better data and move forward, which I believe is the real strength of life cycle assessment and declaring the environmental impact of products. So I'm going to pull down the slides for a little bit here and just kind of open things up a little bit, maybe start with a little bit of discussion. Jacob and Chris, in turn, maybe a deeper introduction from your own standpoint, what brought you to here, and many thanks for joining us.
Great to be here. Chris, you want to kick us off? Shall I?
Go ahead.
Okay. Well, hi everyone. Jacob Racusin. I tend to wear two hats in this space. One is I'm one of the co-founders of New Frameworks, or I'm director of building science and sustainability. You may know us as a design build company. We recently transitioned fully over to prefabricated straw and wood fiber insulated panels. So we are really thrilled to be working with the Timber Fill product as well as the Timber Board product in the fabrication of our panels. We deliver custom panels for to architects and builders for custom projects, as well as a line of about a half dozen pre-designed and prefabricated small homes that we deliver. So both on the use side of things in my New Frameworks hat on, I also wearing my Builders for Climate hat on, which will be more the hat that I'll be keeping on my head for the sake of this webinar, where we've been doing a lot of research into embodied carbon and biogenic carbon storage, and so the analysis of all this work, as well as the development of the BEAM tool. So talk a little bit about the BEAM tool and upcoming changes and improvements to the BEAM tool, which will include more of this wonderful data to help us make better actionable decisions around material project attributes.
Thanks, Jacob.
Cool. Yeah. So, hi everyone. Thanks for joining us this afternoon. Chris Magwood. I'm with RMI, or the long form of the name is the Rocky Mountain Institute. I come from a 25-year career in residential design and construction, and it was great to see that. I never knew that the HP in TimberHP was it had the three-legged stool thing to it, but that's really great because, I've kind of recently become an embodied carbon guy, but I started being a builder interested in all of the aspects of, environmentally sound construction, high performance, healthy people, healthy planet, all of that stuff. And for my own practice, got really interested in the embodied carbon thing because that felt like a missing piece. We had been tracking things like the performance of the buildings, blower door tests, energy modeling, all of that kind of stuff, looking at health data. There were all kinds of metrics that we were using already. And then I kind of had in the back of my mind, yeah, but all these materials, like what's the in particular the climate impact of that? And that sort of, has led me down this embodied carbon path. I did help develop the BEAM tool, which started as just like a tool within our own practice to use, and sort of became a free tool that's out there for people to use. And over the last couple of years, a big part of my work has been shepherding the RESNET 1550 standard, which just got published at the beginning of March. So that was about a 2-year development cycle. But what 1550 is, I see some people said in the chat that don't really, know much about it. So very quickly, what it is it's a standard for how to calculate, report, and verify the embodied carbon of homes. And it was specifically designed to work really well in the workflow of people who are in the energy rating, energy modeling space. So it's a standard that enables you to do embodied carbon assessments, leveraging all of the stuff that you've done. If you've made an area-based model of your building for energy modeling purposes or anything like that, those are kind of the key inputs that you use to form the basis of an embodied carbon model. So with that standard sort of being out, we hope it answers one of the big questions in life cycle assessment, which is, what did you count and what life cycle modules did you count? We all have to be kind of counting the same thing in the same way for the results to be comparable. And so it's really exciting now to have this, nationally published standard available to get us on that path of kind of doing the same thing in the same way. So excited to talk about how all of that, blends into this conversation as we go.
That's great, Chris. Thank you. And so it sounds like how long have you been working on the ResNet 1550 standard? Has that been
It was
a
about a
relatively recent?
two-year process from, getting it started with ResNet. And if anybody is on the call who's involved in the NEHRS, the Northeast HERS Alliance, that group was, the folks that got that ball rolling. So big shout out to them. So yeah, between forming the committees and doing all the work and doing all the public review, it was about a two-year arc there.
And so that is, and you mentioned it's HERS rating. So we're talking primarily about residential, single family. Is there a multifamily or other construction types that get wrapped up in this?
It can be used for any construction type. I mean, in theory, you could use it to model a skyscraper if you wanted to, but it sort of fits the workflow of anybody. So if you're doing a HERS rating in Canada, if you're doing, if you're an energy advisor, if you do passive house, like all of those systems sort of ask you to build an area-based model of the building. So it works, the standard works best for any building that is having an energy model made based on area.
Gotcha. And so that that would get wrapped up in the workflow that the rater would perform. Is
Yeah.
this something that adds additional time or work? Is it a burden? Is this something that's going to become widely adopted? Is it directed by code?
Right.
Curious
Well,
about
that's, after you do one of these standards, then you start publicizing it and getting it out in the world. So we're going to, over this year, be working on training, certification, promotion. I put a link in the chat to the standard if, you want to go and check it out. But yeah, I expect it will start to see its way into, various embodied carbon incentive programs, regulations, state and city level kind of programs. I have high hopes that maybe as the Canadian federal government is looking at putting embodied carbon into the codes here in 2030, would love to see that standard play a role in that. So, you kind of have to build it first and then hope that people come. So we've done the build it part, and now the next sort of task is to get it out into the world and get it sort of used and adopted.
I
And
know some
in
of the
terms of
provinces. Go ahead.
I was just going to say, in terms of the utility and the friction, in terms of like conducting additional assessments and like what it takes for a rater to accomplish, adding that onto their scope in addition to the energy rating, that what we're working on with the Beam tool right now is the number one, make it a full 1550 compliant tool so that all the things that need to be in there are in there, and it's super easy to conduct an assessment using the Beam tool. So that's under development right now. We'll have that rolled out a little later this year. And we're doing that in coordination with some of the leading energy modeling tools to try to reduce the friction for a rater or an energy advisor. They've got all their inputs in their energy modeling tool to have that cascade into the Beam tool really effectively. And then we'll be able to leverage a whole lot of more advanced integration as we move on and get a sense in the rating community of what they need and how it works. So from the tool makers side, I can say that we're working really intentionally right now and trying to reduce that friction and make it super easy to enact the standard and actually conduct assessments at scale.
Yeah, and to your question, it's definitely, there is a bit of extra lift to it because we need to look at some things in an embodied carbon model that you don't typically look at in an energy model, right? Your energy model doesn't care about interior partitions, but there's a lot of material and sometimes high embodied carbon material in interior partitions. So 1550 says, well, we need to count that. Or, in your energy model, you don't really look at the footings under a foundation wall, but 1550 says, well, we need to look at footings. That's a high carbon, place in the building. So you have to sort of count all the things that you do count in an energy model, the windows, the walls, the insulation, all that kind of stuff. But then there's additional things on top of that. So that's sort of the extra lift is, you need to also know the square footage of your interior walls and your doors and your flooring and, stuff like that.
So yeah, a little bit more granularity, it sounds like you're getting
Yeah.
into at this point.
Yeah.
Yeah, not for efficiency. It's interesting. I spent quite a bit of time earlier in my career on the retrofit side of things, and not so much in new construction in RESNET. It was home performance. It was maybe living and working here in Maine with an existing housing stock as the predominant housing stock that we don't fill in with new construction as much.
Yeah.
That energy efficiency was and still is very important.
Yeah.
But this shift to carbon doesn't change that at all. But it does open
Hmm.
up additional questions. It really
Mm.
broadens
Hmm.
the conversation around not just how a building operates, but what are
Hmm.
the core bits that really make a big difference all in when we look at
Yeah.
this much larger perspective.
Yeah. And there is a pathway in 1550 for retrofits, and
Hmm.
it's pretty straightforward. It's don't count the embodied carbon of anything that already exists in the building because that's old emissions. We
Hmm.
can't really quantify those. So count everything that's new in the retrofit. So same calculation, same everything, but if you change the cladding, then you would need to do the embodied carbon of the cladding. But if you left the cladding, you don't. So, you're basically doing an embodied carbon calculation of the new things that you've added to the building.
Yeah, yeah. Yeah, it looks like a lot of folks in the chat when they first chimed in are very familiar with 1550, some not so much, and certainly many familiar with the beam tool. Maybe we can drill down a little bit more and describe these tools in a little more detail on each side or how they wrap together. And Jacob, you said that you're really looking at rolling the 1550 into the beam tool. And
Hmm.
I've heard of beam as sort of like the right sized tool for assessments of homes. And what, if anything, is and how does this different from a full life cycle assessment? What is it that beam has presented for those that are not familiar with the tool? And where is it going? Maybe go a little bit more in depth with where you're seeing it in the future as you plan this out or code this out or however you're bringing this new light to Beam.
Well, actually, can I
Thanks.
can I jump in on the first part and
Please.
you can do the development? So, because I
Absolutely.
mentioned before, Beam started as a personal tool, right? Like for me, I wanted to figure out how to do embodied carbon. So, you know, got all these EPDs and figured out how to pull the right information out of them, but realized because as a design build firm, we changed the size and shape of our buildings, but we often don't change the things that go into them. And so what I wanted was a tool that allowed me to look at any amount of either full building area or assembly area and be able to see the embodied carbon of that and
Hmm.
and and change the output based on the dimensions going in. So we ended up with this dimension-based system. Like this project has 1,000 square feet of wall, and then I specify what drywall and what insulation and what cladding, blah blah blah, and I get an embodied carbon number. If I want to now make 2,500 square feet of that, same wall system, I just change the number from 1,000 square feet to 2,500 square feet, and boom, I get the embodied carbon of all those same components out of that. And so the tool was very much built out of like I wanted something that was of great utility to me as a design builder. And so I think what people have found helpful about the tool is if you think about things as a design builder, it suits the approach. It's assembly based, so sort of every sheet in this big Google spreadsheet is a different assembly. Here's my foundation and footings. Here's my foundation wall. Here's my exterior wall. Here's my roof. And then all the products that you would need to build that are in those particular assembly tabs. And so, yeah, the development came from just making something that was practical to use for me and my team. And then it turns out, oh, there's a whole bunch of people who find this very practical and easy to use. So that's kind of the genesis. And then I'll turn over to Jacob for the like where it goes from here, because that's a whole other
Yeah.
thing.
So yeah, building off of where Chris kind of left off from there. I mean, the current utility and the value that we've seen moving it from this essentially like internal research tool into something for our market, we were really seeing it fill a need that was not being filled by other life cycle assessments tools, which really tend to come a little more from the architectural community and the commercial sector. You have a BIM model that you can leverage for your inputs, or you have a bill of materials that's, organized by CSI division, something along those lines. And you have all these materials that are, pretty well aligned with larger and commercial scale construction. And we're seeing that, within the low-rise residential space, or even like the multi-unit space, where there may not be a full fleet of architectural engineering services available, where, to Chris's point, you may be thinking about your building more on an assembly basis, and your inputs are more around, area based, as opposed to, I'm going to make a full bill of materials of every, stick going into the building. You find even amongst the production home building community, like the larger scale builders, they don't even necessarily have full bills of materials and fully developed BIM models that have all the encoded information to go right into an LCA tool. So there was a real need, and that's where the real value of BIM shows up right now. Even using on commercial buildings as an analyst, as a consultant, I would use BIM pretty regularly for doing assembly studies in the middle of design development or early phase design modeling, before you have a BIM model fully filled out, so on and so forth. So still holds a lot of value there. And I think the other thing that BIM fills a niche for is the inclusion of a whole lot of bio-based materials and a very explicit methodology that shows the emissions as well as the carbon storage and then the net value, so that it's just very transparent and detailed around the data associated with both emissions and carbon storage, and how we can strategize making better decisions around that sort of broader, more detailed view of the information. So where we're going is, number one, I know I saw in the chat a lot of people have some familiarity with Beam. I'm really happy to say we're going to be moving it off of the Google platform, which has been really helpful to get a free tool into people's hands immediately. Like, that was one of the goals, of just like keep it as a spreadsheet, keep it something, a free platform. It's easy to distribute and update, and just kind of keep moving forward quickly. But we've definitely outgrown that platform, and the functionality that we're excited to bring in is pretty diverse. So I mentioned we're going to make this a 1550 compliant tool. So that means a lot more types of materials. I'm super excited that we're bringing mechanical, electrical, and plumbing data into the tool. I was behind a lot of the research to get those default values into the 1550 standard. So we put a lot of work into actually getting good numbers for mechanical, electrical, and plumbing, which have been some of the most data scarce parts of the sort of material environment to date. So we actually have some of that information and can bring that into the tool. So that's gonna be a really big advantage. We'll have a web-based version of the tool, so it'll be a lot easier to just jump on and start using it. I mentioned we're looking at integration opportunities with other energy modeling tools, both so that the inputs that go into an energy model can cascade into Beam, but also so we can get energy and operational carbon data from those tools into Beam, so you can co-analyze for both operational emissions as well as the embodied emissions, and have that within one kind of tool environment to look at analysis. We're going to be diversifying the different ways to get inputs into the tool, instead of just manual entry or starting from an energy model, but being able to get PDF readers and some BIM model kind of integration going for inputs into the tool. So yeah, a whole host of things that are going to be coming out in the pretty near future. And then we're also setting up a backend structure to be able to bring in additional material attributes. We're already researching health and overlaying health attributes with embodied carbon, so that will be able to come into the tool. And we've heard a large demand around getting costing information brought right into the tool. So there's going to be a bunch of cost data that we'll be able to bring in as well. I'm not promising all of those pieces will be in place in the next version. Some of those additional attributes will be coming out, in an iteration 2 further on. But yeah, we are migrating to a platform that's going to make those updates and changes be able to move really quickly, as well as just more data and more automated data. So we're moving from a manual data update process, because that's kind of what's required in our current platform, to a much more rapid and kind of real-time data update process, which correlates well with the fact that so many of these EPDs are now digitally produced. When we started this tool, it was literally running through thousands of PDFs, or hundreds of PDFs at least, and getting that information in place. And boy, has technology improved in the last X number of years. And so being able to automate the updating of that data is going to be a really fundamental part of the next rollout.
I'll just say too, one of the other things that worked for V1 of Beam and then the public version is, for our team, what was really helpful and what was missing in lots of the other tools was you kind of had to make a fairly complete model and then tell the model what products you were going to use, and then you would get this result. But if I wanted to, in one of the sort of the tools I was trying to use before I made Beam, it's like, so if I want to toggle this insulation product to that insulation product, I have to go back to that model, choose that other
Mhm.
insulation, and then compare the output. And what I really wanted was, what are all the insulation products I could use? And let me look at them all at once. So, the very first iteration of Beam was, if I had my 1,000 square feet of wall and I needed R20 insulation, like, I wanted something where I saw every single product in that category and its embodied carbon at 1,000 square feet and R20. And that's how Beam
Yeah.
still works. And I think even as it gets all of these, fancy things that Jacob has, I think that that comparison function is
Yeah.
still going to be core. Like, how do I look at products in the same category and like see how they stack up against each other in one glance? And that's still kind of, I think that'll stick through future developments.
Yeah, that's
Absolutely.
but we do have a question, and that is, when are we going to get to the HP product? And I I appreciate that from the audience. I mean, it is a Timber HP webinar, and we've been talking about all sorts of other things that I think are very related, and maybe some haven't gotten a deeper dive on our product, which we're still not going to get into here. But maybe to put you on the spot, Jacob, we could talk a little bit more about how, because our EPD is just recently published, you've got a lot of work getting all of this manually entered, and you're working towards a great deal of automation to pull that information. But would you mind sharing a little bit about Beam Tool and how you might pull some of our or another manufacturer's information in?
Yeah, so I'll go ahead and share screen and just give a really quick tangible example of this and tie all this yammering about Beam directly to how you would be able to evaluate a product like TimberBatt. And congratulations on the EPD. For those of you that are unfamiliar with the development process of EPDs, this is non-trivial. It is a huge commitment on behalf of manufacturers and a whole lot of expense to be able to produce these EPDs. So kudos and reward manufacturers for product transparency, because it's super important. So thank you all for doing that. So just to make what I was saying a little more tangible, let's say we want to just do a really quick study on materials like Chris was referencing. This is the first page of the tool. You can see it's organized like a spreadsheet. You can just throw in 1,000, in this case, meters squared. Don't fear. If you need to speak IP, you can toggle to, IP units. I'm just going to keep it metric for now, but that's, don't worry. This could be feet squared if that was your preference. I'm just going to throw that number into the exterior walls so we can then just go start looking at comparing some different insulation materials. You'll see all these different building assemblies show up as different tabs in the spreadsheet. If we go over to exterior walls, we zoom up a little bit here, and let's see, we want to go to the category that's looking at a cavity insulation. We have all these different cavity insulations that we can look at. Just to be really clear about what we're seeing, we've got our gross emissions. Those are the emissions released from the production of the material. And then we've got where carbon may be stored if for a bio-based material. And then we subtract the storage from the gross emissions and we get the net. So in the case of some of these plastic-based installations, which tend to be more carbon intensive, that's why we see them at the top of the list. The list basically goes from the most intensive to the least intensive emission products. And so, yeah, these plastic ones don't have any biogenic storage. So they're just showing those gross emissions as the total emissions. And we can scan down until we get some BAT products. And I want to compare a couple of different BAT products together. In this case, for mineral wool, we're just taking an average of all the different mineral BAT products that are in the tool here. To select that, I just click the box and let's add some fiberglass in there. In the case of fiberglass, NAMA, the trade association, releases an industry average EPD. So we're going to use that one just to look at an average fiberglass BAT. Beam has sheep's wool insulation, and here's where we start to actually see some carbon storage values. It's a bio-based product, and instead of having that sheep's wool go through its lifespan and biodegrade and go up into the atmosphere as methane or carbon dioxide, we're diverting that from its end of life and putting it as the feedstock into a product product that lives for a long time in the building. So we can assess that carbon storage value and then give it a credit by subtracting it from the gross emissions. In this case, it takes more emissions than it stores, and so there's still a positive emission number. But in the case of hemp fiber, it actually stores more carbon dioxide equivalent by mass than it releases. And so that starts to show up as a negative number. There's a cellulose bat. I clicked that one as well. There's a couple of wood fiber insulation products already in the tool from Europe. And boy, am I excited to update the database, bring TimberHP's tool in here, or a product in here. Didn't get a chance to do that before this webinar, so I just added it into the tool, go all the way down to the bottom, and there's a place you can add a custom EPD. So just to make it really tangible, like how we translate taking an EPD, so I'm gonna move my Zoom menu out of the way here, as taking an EPD and putting it into the tool. So EPDs show up to these PDFs here, and this is the one that Jason was highlighting earlier. There's a ton of good information here about the product, about how the product is developed, all of the information of the product, like its biogenic carbon sourcing. It talks about the methodology of how the carbon is assessed and the storage is assessed for this product. So there's some really good background information there. If you ever wanted to know how TimberBatt is produced, there's a beautiful infographic that shows all of the processing here. So even if you aren't super interested in the data, this is just an awesome publication to just understand more about the product and how it's used. So I'd highly recommend people that are curious about TimberBatt to just take a look at this and see what's gone into making this amazing product. More and more information, and then finally we get to where the good data is here. And so it's broken down by all these different parts of the life cycle. Beam looks at A1 to A3, the product emissions, all the emissions that takes from going from taking raw materials and turning them into a product. And that's basically broken into these three categories. A1 is essentially like the growth phase of the plant, if you will, or the raw material extraction. In this case, the raw material is not extracted, it's grown. So we see this negative number here because of all the carbon dioxide that was photosynthesized to create the physical structure of this woody matter that goes into the product. A2 is transporting that to the manufacturing site, and A3 is the manufacturing itself, and we see some positive numbers there. So I took these three numbers and I plugged them into the Beam tool here. In the storage, that was that negative number. In this case, you can see rather than expressing it as a negative emission, I'm calling it a positive storage value, and I'm multiplying it by the same 1,000 square meter unit. And then on the gross emissions, the emissions that were released, those are the A2 and the A3 emissions. We add those up and multiply those as well. And then as per the methodology, we're subtracting the storage from the gross emissions and we get our negative number. And so when I select all those BAT products and I want to compare them to each other, I go to the review tab, and here they all are lined up next to each other. This process took me about 5 to 10 minutes. If you're a new user, maybe it would take you 15 to 20, but it's really, and that's including taking the data from the EPD and putting it into the tool. So this is a really straightforward process. Once TimberBatt's product is in the tool, you won't have to go through that manual step. But just to get a sense of how TimberBatt as a product is stacking up against these other ones we selected, we can see, I would say we're within like the margin of error of Gutex. It's showing up better by about, either side of 10%, 10, 12%, which I'd say for the accuracy of EPDs, we'd say is more or less within the margin of error there, but like significantly better than some of these other products. And it's really interesting to see that even some of these carbon storing products have a pretty significant emission profile to them. I always find that kind of interesting with wool, that it has a really good carbon storage value, but it takes a fair amount of process energy relative to that. So it still shows up as a positive number. Some of the best in class materials here are the ones that are relatively low process emissions with a whole lot of carbon storage. And so you end up with a larger negative number, and that's awesome. So I know that was a little bit of a whirlwind. I'll stop there. Yeah, come in on it, please.
Yeah, I was just going to jump in to say, and maybe we'll get into this a bit later, but there is a lot of debate about, how to think about carbon storage and stuff, and I'm very glad to go down that path because I think it is really important. But one thing you can also do is like if you're of the opinion that all this carbon storage stuff just doesn't matter, then just block out all those other columns and just look at the gross emissions column. And what's interesting to me now that there's this TimberBatt EPD is that, storage aside, this is the lowest emission product in this suite of options. So even if you're not like, I don't want to count storage, I don't know how to think about that. Great, don't. You could just look at emissions and in this case, you can just look at that column and sort of make some decisions based on that.
I was surprised in doing a lot of research and trying to figure out how we report this and looking at the European standard, and I believe there are some variations or nuances to how things are accounted for and recorded depending on country. But overall, when we look at some of the other wood fiber insulations here before us, pretty commonly known, it really gets down to their energy sources, and what they're burning or utilizing in order to get to that number. And I think that's the big difference between the two above us is their energy source in manufacturing.
Yeah.
We are electrical is met hydroelectric on facility. We use natural gas for our thermal. We would love to be able to leverage cogeneration, other waste products, but we're not quite big enough or rich enough to get that level right off the bat. So a lot of
Yeah.
investment up front. But this is
And
fast.
that's a great point, Jason. People often ask like, well, why is so and so's fiberglass bat so much lower or higher embodied carbon than the other companies? And it does basically come down to efficiency of manufacturing and fuel sources for that manufacturing. So, if you're melting your glass with coal, you are going to have very different emissions than if you are melting it with natural gas, than if you are melting it with some sort of electric process. And so the cleanliness of the grid where those factories are, and both the efficiency and the fuel source of the manufacturing is what makes that difference. So that's why some manufacturers' products look better than others.
Yeah, it's fascinating all the parts that come into to all of this. In the end, it really does matter when we start getting into the weeds, if you will. I know we have looked at this cradle to gate aspect of it. This is what we are required to report. And is Beam looking at a broader scope? Does the RESNET 1550 look at something broader? Are we talking about a whole life cycle in the end? Or are these just bits and pieces of it?
Yeah. Well, maybe I'll address that on the 1550 side, where, that was definitely the thing we spent the most time in committee kind of talking about. And in the end, it is, in this first iteration anyway, an A1 to A3 methodology. So that is what we're looking at, those product emissions, not out of, interest in or concern for the full life cycle. I think, we would like to get the standard there at some point. But for two things, in the interest of getting something out into the world sooner than later, we have really good A1 to A3 data. That's if you've heard from anybody that, oh, there's not enough EPDs and all that kind of stuff, not true anymore. Like, in that A1 to A3 category, we can model a residential building pretty darn accurately on the product phase. The product phase is also where the majority of the emissions over the life cycle live. Depending on the product type, it's like 60 to 85% of everything that product will emit over its lifetime happens there. And as a tool, and for RESNET as a standard designed to help designers and builders make choices, the thing that a builder and designer can choose is, what is the product? The further the other life cycle stages get, harder to find good data. So, A4 is transportation to site. Well, some tools, some standards will give you some very rough, like, general kind of numbers, like add up the weight of the product and times it by, this many miles or kilometers of transport as an average. And there you go, there's a number. And it's like, well, yep, that's a number, but does that number help a builder or designer make a choice? Not really. And especially in the residential market where an awful lot of our supply chain comes through retail suppliers,
Hmm.
that's a very obscure what goes on, behind the shelves at a Home Depot or a Lowe's is complex and obscure. Like the product does not travel from your factory, Jason, to a job site. Like we can't just say, "Oh, I'm 200 miles from where TimberHP does their thing," and think that that's how the transportation works. Like even for a small manufacturer like you, like it goes somewhere else, it goes somewhere then, and then it sort of makes it to a store, and then it gets from the store to the job site. So it just felt like can we give any helpful, useful information, on that part of the life cycle? It just felt like the answer was no. And then the use phase, the stuff that happens, around maintenance and repair and replacement, same thing. And I think again in the residential context, I think for commercial buildings, when somebody chooses a flooring in a hospital, they're pretty darn sure that they know that that flooring is going to last 20 years and then it's going to be replaced.
Right.
You put flooring in somebody's home, I don't know, my last home that was 100 years old had the same flooring that it had when it was built. But, and if it's going to get changed, life cycle assessment wants us to say, you're going to swap the same product for the same product. Again, I think that maybe works in the commercial setting, but I think in the residential sector, one of the reasons people change products is to change the product. Like, I don't want this floor, I want that floor. I don't like this cladding, I want that cladding. Anyway, I think without going into lots, there's a lot of complexity about predicting what's going to happen in the future. And I think it's important, but I think we don't want to just fill the space with a whole whack of placeholder data and think, hey, we're complete. We did the life cycle, but we gave you a bunch of like weird approximations for all of these things,
True.
go make sense of it. So I think, I would like to do a lot more study. I would like to understand a lot more like the best ways to do those parts of the life cycle. But in the meantime, we can make really good product choices here and now by focusing on that.
Yeah,
And
and
what I
for,
can say,
for
oh,
structural and insulation, we're not talking about maintenance, hopefully.
Yeah,
Uh, Generally, we're not going back to kind of touch it up and,
yeah,
uh, fluff things or something like that. And we shouldn't have to at that point. So it's
no,
oftentimes for us, it's not much of it. We did include and pay attention to installation because there's some relevancy there based on other
yeah,
materials.
yeah,
Certainly, if you're by hand cutting and fitting something, that's one thing. If you need a very expensive gas tool to do it, that's another thing.
yeah,
And if you're combining chemistry on site, that's another thing entirely. So,
yeah,
yeah, certainly can play into it for sure.
yeah.
You're going to add something, Jacob. I didn't cut you
oh, I
off.
was going to say briefly, kind of. No, I was jumping on you. Yeah, you made great points that I was going to kind of poke out there, Jason. So I won't repeat what you're going to say. I'll just say from the beam side of things, I think we are very interested in having the full life cycle represented because there are some points where it will be really useful, and there are some considerations. Like one that jumps out for me, I know I'm a bit of an MEP nerd, but like refrigerant, for example, is a
Mm-hmm.
really significant category of emissions. It kind of dwarfs everything else in those categories, but it tends not to really get released, with some exceptions. And maybe if there's a mistake, it may get released during the installation phase. But often we'll see the release happening either through leaks during use or at the end of life when it's not recaptured. And so there are big plumes of emissions that happen there that are meaningful, and that can direct better actions around commissioning and the design and management of refrigerant-based heating and cooling systems. And we don't have visibility into that without looking at these some other phases of the life cycle. So that's a great example of where we may like really want to see those other phases to be able to take more actionable decisions. So we are very interested in seeing that. We're doing a lot of research right now, to Chris's point, of what some of those next stages of the upfront emissions look like from the residential sector. Right now, it's a little more like a placeholder value than actionable decision-making value. But the one thing I hear a lot about is, well, if you're going to use some of these bio-based materials and they're going to rot out twice as quickly, then you have to replace them as often. Then like, don't you want to see the whole life cycle to see that? And I would say, well, one, If you are looking at two different fully equivalent products and one lasts significantly longer than the other, then yep, that's something that might be useful in life cycle assessment. I'll be really clear though, I don't see in my practice, particularly as having started a weatherization division of our company and been working in existing buildings for, well over a decade, there is nothing inherent to the bio-based materials that lose their value any more or less quickly than mineral or petrochemical based materials. And in fact, I see more rot issues coming with poorly installed plastic based materials because of like poor management of moisture than I do because of a bio-based material not serving well. I mean, those are really assembly level decisions
Yes.
and quality of construction and quality of like design that incorporates best practices of building science. So I would say upstream of the how long does the durability of that specific material, what we find, particularly with assemblies, you like insulation and kind of like primary control layer materials, not so much the finishes and mechanicals, like those should all last the lifespan of a really good high quality building. We have straw bale construction built, during the westward migration that's well over 100 years old that is still standing. Like we can do this. This is feasible. There's nothing inherent to these materials when applied well that makes it necessary to look at the full life cycle to calculate whether or not it's going to have some cascade of emissions if it needs to be replaced. I'd say solve the problem at the root, which is building to best practices, read the manual, look at it from an assembly level, and use all the great resources that you put out on your product and that other manufacturers put out about their products to make sure it's actually going to last as long as it should. I'll just name that bit of myth that associates with bio-based materials.
Yeah. And I would also say, the argument, I think, by giving people the data, like we're not necessarily saying the lowest number in this tool is the best product for you to choose. This is a decision making point, like along with a whole bunch of others, cost, availability, like lifespan, all of those things. And at this point, we also trust that people in this space are smart enough to go, oh, like this cladding product lasts 20 years and has this upfront emissions. This other cladding product lasts 50 years and has this level of upfront emissions. I think that's a decent, trade-off, or a decent way to think about the emissions. So it's not, this isn't a game of make the building and tick all the lowest boxes in beam. This is make a good building and take those numbers in beam into consideration as you make those decisions. And also think about, like, one of the things that beam doesn't illustrate, but I think it's important for people to know, is like when a product has high emissions, that means when it was made, those emissions went into the atmosphere. Emissions, greenhouse gases in the atmosphere don't just like go up today and they're gone next week. Like they stay in the atmosphere and accumulate warming. Like there's the blanket analogy, right? Like if you put a ton more emissions into the air, you've put another blanket on yourself or on our whole planet. When you're living under that blanket, you get warmer and warmer and warmer. So, I've had lots of people say, well, for embodied carbon, I should just make a concrete bunker because it'll last forever. And it's like, things won't need replacing. It's like, well, yes, but the amount of emissions you released to make your concrete bunker, like make the planet warmer for the next 1,000 years. If you use something with half the emissions and you had to replace it once along the line, like that is way less cumulative warming than that big burst at the beginning. So like that's something it's hard for the tool to sort of describe, but like the durability at any climate cost is not a great argument. Like it's it may be better for the planet if you had an ultra low and affordable cladding that only lasted 20 years. If you could afford to replace that, the emissions profile is probably better than coal-fired brick done once with really high emissions for the next 100 years. So I think these are data points, and then the interpretation of them, like smart designers and builders out there make judgment calls on multiple factors all the time. This is just like, here's another data point. it's a really useful one, especially if you care about the climate. But it, I don't want people to get the sense that the whole point of doing a beam model is to get the lowest possible score. Like it's
Yeah,
the lowest possible score that still meets all of your other building
exactly.
needs. That's
Exactly.
that's what I hope people use it for.
Yeah, that's great, Chris. We're getting close to 5 minutes left. I wanted to maybe drill down a little bit more in bio-based and carbon storing or upfront emissions, and I think you have a graphic that kind of lays that out real well. We did get a question from a colleague to the north, at least for me. Peter Moonen was asking the both of you if there's a significant difference between Beam and the MCE2 tool.
Oh
I'm
yeah.
not familiar with this tool, but maybe it sounds like you might be. Can you speak to that?
Yeah, so the MCE squared tool is a tool that's provided by the Canadian federal government for doing residential embodied carbon analysis. We're also behind the data behind that tool. We didn't develop it, but we help support the databases from it. So they're very similar. There's some key differences there. The data sets tend to sort of like leapfrog each other, so they're quite similar, but with some minor differences, mostly based on updating schedule. I'd say one of the biggest differences you'll find in the MCE's tool square is that it is integrated with HOT 2000, which is the Canadian residential energy modeling tool, and it brings in some of that information into MCE squared. We're going to be doing that with Beam coming out in the next edition later this fall, so that will make them a little more equivalent there. But I'd say they're from like the squinty-eyed view, especially compared to like all the other LCA tools out there, they're very comparable. I would consider them to be from like from a larger vantage point, like pretty functionally equivalent in terms of the markets they serve, the way they're organized, the fact that they use EPD, like product specific data, as opposed to LCI data, which is more sort of generic data to cover, more like all the life cycles you'd find with a more of like a commercial type of whole building life cycle assessment. So yeah, quite comparable in a lot of ways, and we're
They're
sort of
broken into
involved
the
with the
same assembly tabs exist in both. It's the
exactly.
methodology is the same in both.
Yeah.
Nice, nice. Great, thank you. Chris, do you
Mhm.
want to talk a little bit more about upfront emissions and the impact? And we've got
Sure,
about
I would love to because
4 or 5.
now that 1550 is sort of not behind us, but the big work on that is done. I have been working on a dynamic life cycle assessment methodology, and I think it's really illustrative for this discussion around biogenic carbon and what does it mean. So working with a few different dynamic life cycle assessment tools, but essentially what they do. So when you get an EPD and you see that GWP 100 number, it's kind of like an amalgamation of what all the different greenhouse gases that were emitted, like what their impact on the climate will be at 100 years. So it's like one number tells you something about one point in time. And what dynamic LCA does is tell you, like, what is the actual climate reaction to these emissions? And so what you're seeing on this graph is just two kind of generic wall assemblies. One, the top one with the red line, has no biogenic products, and the one with the green line has quite a few. So you can see this is what I was talking about with the concrete bunker example is when you have a product that has emissions, basically what we're looking at is degrees Kelvin. So like actual the difference it makes to the temperature of the planet. And you'll see by the numbers, we're talking very small numbers because we're talking tons of emissions, not, megatons of emissions, but still, you make this assembly and you can see, the product was made here at year zero. It emits a whole bunch, and you can see the climate gets appreciably warmer quickly. So, within a decade of that product being made, it's like the climate is warmer. There's a slight tailing off as some of the gases that break down faster sort of tail off. There's a little blip here for end of life emissions. I made end of life 60 years on this one. But you can see basically that red line is just going to keep going for about 1,000 years. So you make a decision today, the emissions go in the atmosphere, you're locking in a whole bunch of warming for the next 1,000 years or so. Down at the bottom, when you store carbon, when you use a product that's taken CO2 out of the atmosphere and instead of returning it, it's saved it. You get almost the mirror image of that, except you're cooling the planet until at year 60, I've assumed here we're going to burn that at the end of its life. It's all going to go back to the atmosphere quickly, and you'll see it does. But here's what the warming profile of that looks like when it pops out at year 70 or so. So when people say like, oh yeah, but those biogenic things, aren't they just going to re-emit again? Yes, but even if they do, the difference between the warming profile of this little blip, which is going to be, it's low and is going to be over soon, versus this big one that happens and keeps going, is substantial. So that's like just a quick graphical representation of like why this carbon storage thing matters. And I'll hopefully have the methodology for doing these calcs out by the end of the year, so people can get a bit more, be able to look at this themselves.
That's great. I love that. I've never been so excited about a little graph before until now. I might even get that tattooed on me or something. We're going to wrap up. Jacob, Chris, thank you very, very much for this. I always learn something new when I listen to you guys. Really appreciate your input. I'm going to try and add the little closing slide here just for more information, questions. Feel free to reach out to us, info at, we have some socials here. We tend to respond in any way possible. If you've got questions for Jacob or Chris, we can add those contact informations to the chat as well, or we can pass things through. We didn't set that up for you guys, but happy to share all of that. And thanks again, everyone, for joining us on this month's Beyond R Value. And thanks again to the both of you guys. Much appreciated.
Yeah, thanks.
Thanks for having us.
Take care,
Bye.
everyone.
All the best.